Welcome to The Explainer. I am incredibly excited to dive into today's topic with you. Between March and May of 2026, the AI industry went through a massive shift. But we aren't here to talk about the hype or some theoretical research that might happen 5 years from now. Instead, we're going to cut right through all that noise and look at the real, concrete AI infrastructure that actually shipped during those 60 days. We're going to use this deck to climb the modern AI tech stack, layer by layer.
So here is our guiding question. What actually shipped in AI infrastructure this spring? To figure that out, we'll start right at the foundation with compute and memory, work our way up through data and security, and finally see how it all comes together at the application layer.
Starting off with Section 1, Fixing AI's Memory Problem.
Okay, let's dive right into this. Before we can even think about building intelligent agents, we absolutely have to deal with the physical bottlenecks. And the KV cache, or key value cache, has been the single biggest physical limitation holding back long-context AI. Think about it like this. When you ask an AI to read a massive document, it has to store the context of what it's reading in its short-term memory. That memory structure is the KV cache. As the context window gets bigger, the memory you need absolutely explodes, which creates a massive cost bottleneck. It's literally the reason running advanced models gets so incredibly expensive at scale.
But then, on April 2nd, at the ICLR 2026 conference, Google dropped a massive breakthrough called TurboQuant. TurboQuant basically acts as a release valve, using a really clever two-step compression process. First, it uses something called PolarQuant to apply vector rotation to the key-value pairs. Then, it uses the quantized Johnson-Lindenstrass method to compress all that data. The true genius here? This drastically reduces memory overhead, and developers don't even have to retrain their existing models to use it. It's a huge win.
And this really signals a broader industry pivot. It's an efficiency-first shift in AI development, moving away from just raw parameter scaling. For the last few years, the entire industry was completely obsessed with just building bigger and bigger models. But this spring, that was the exact moment the focus shifted toward getting a lot more out of the architectures we already have.
So what does this actually mean for us? Well, for massive data centers, lower KV cache memory physically lets them run way more concurrent sessions on a single GPU. It fundamentally changes the economics of scaling AI. And for everyday consumers, it opens the door to bringing highly capable long-context AI straight to constrained on-device hardware. We're talking running advanced models right on your phone or your laptop.
Moving right along to Section 2, Agentic AI meets enterprise data.
Right, so once you've got the compute bottleneck solved, you need data. And Oracle released a pretty dense technical update this spring focused on integrating autonomous, agentic AI natively into the database itself. They shipped the Autonomous AI Vector Database, the Private Agent Factory, and the Unified Memory Core. Now let's look a little closer at those last two, because they are absolute game changers for the enterprise.
Now, what's really interesting here is how the Private Agent Factory solves a massive real-world blocker. If you're in a highly regulated industry, like finance or healthcare, data privacy is everything. You simply cannot send your secure data out to a third-party AI provider. So this no-code builder lets internal business analysts build and deploy intelligent agents entirely within their own secure environment. You get the AI power without ever sharing your data outside the company walls.
Furthermore, Oracle introduced the Unified Memory Core. They essentially merged vector, JSON, graph, relational, and spatial data into one single engine. Think about how big that is. Previously, if an AI agent needed to analyze a structured spreadsheet alongside an unstructured text document, it had to jump between separate systems. Not anymore. This converged engine is a huge leap for multimodal reasoning. Agents can now instantly understand complex business context across completely different data formats.
Which brings us up to Section 3, Securing Autonomous AI Agents. Think about this for a second. When you give AI access to all this enterprise data, and you give it the ability to actually take action, a pretty terrifying question pops up. What happens if these agents go rogue? The old legacy model of chatbots was just about what AI says. If a chatbot hallucinates, it just spits out some weird text. Annoying, but mostly harmless. But in the autonomous era, it's about what AI does. We're talking about agents calling APIs, modifying files, and triggering downstream supply chains. Legacy security models are fundamentally broken for this because they only monitor text outputs, not independent actions.
To fix this glaring blind spot, Palo Alto Networks launched Prisma AIRS 3.0 back on March 23rd, and it covers the entire lifecycle. First off, it automatically inventories all the AI agents running in your cloud. Second, it runs simulated red teaming attacks to try and break things, surfacing vulnerabilities before you ever go live. And finally, it deploys an AI agent gateway to give you actual real-time protection while the agent is actively running. The crucial takeaway here is that we are witnessing a fundamental shift in how we secure technology. We're moving away from static configuration time rules and moving toward runtime behavioral governance. If you want to secure an AI that takes autonomous actions, you absolutely need real-time identity controls and constant behavioral monitoring. It is entirely about securing what the AI does, not just what it says.
All right, moving to Section 4, AI agents as digital teammates. Let's move to the top of the stack and see how this all builds together. We have the compute, the converged data, and the security in place. Now for the applications. In April, AWS expanded their Amazon Connect platform into 4 very distinct, purpose-built AI solutions. You've got decisions for optimizing the supply chain, talent for hiring workflows, customer for engagement, and health for healthcare administration.
To really grasp why these AWS tools are so revolutionary, we have to talk about a vital new concept: humorphism. This is a massive mindset shift. Instead of treating software as a static tool you just click on, you treat AI as an adaptive digital coworker. These systems are actually designed to learn your specific business context, adapt to how you work over time, and truly collaborate with human employees.
And the speed of adoption? It is literally staggering. It took United Airlines just 3 months, to go from a simple concept to having these agentic systems live in full production using this new infrastructure. So the real so what of this entire stack coming together is that the enterprise AI deployment timeline has definitively collapsed. That combination of better memory, converged data, and built-in runtime security has completely changed the game. Projects that used to take years of messy, custom integration are now shipping in a matter of months. And finally, Section 5, the future enterprise AI stack.
We've just taken a massive journey, all the way from solving physical memory bottlenecks right up to deploying digital coworkers in the airline industry. And remember, all of these concrete advancements shipped in a single 60-day window this spring. So I want to leave you with this final provocative thought. How is your organization's infrastructure preparing for autonomous agents? Because as we've seen today, the era of simple chatbots is already in the rearview mirror. The infrastructure for autonomous agentic AI is here right now. Thank you so much for joining me for this explainer, and I highly encourage you to go take a hard look at your own tech stack with these breakthroughs in mind.